Arduino. So this is the code for the Spaceship interface. Seen part 1 of the video where I put the breadboard together, and this is the code bit. So I'm still following the same Arduino projects book, and I'm just going to talk through what I'm doing as I do it. So I'm just going to read the notes before you start. Every Arduino program has 2 main functions. Functions are part of a computer program that runs specific commands. Functions have unique names and are called when needed. The necessary functions in an Arduino program are called setup and loop. So I can see those already on my screen here. Setup and loop. So I've just opened a blank sketch, which is what Arduino calls programs. These functions need to be declared, which means that you'll need to tell the Arduino what these functions will do. Setup and loop are declared as you see on the right. In the program, you're going to create a variable before you get into the main part of the program. Variables are names you give to places in the Arduino's memory so you can keep track of what is happening. These values can change depending on your program's instructions. Variable names should be descriptive of whatever value they are storing. For example, a variable named switch state tells you what it stores, the state of a switch. On the other hand, a variable named x doesn't tell you much about what it stores. So that's the introduction bit. It says let's start coding. To create a variable, you need to declare what type it is. The data type int will hold a whole number, also called an integer. That's any number without a decimal point. When you declare a variable, you usually give it an initial value as well. The declaration of the variable, as every statement must end with a semicolon. So they've put this before the setup. So it's the first thing we do is to declare it, which is int switch state equals 0 and end with a semicolon. And then it goes into void setup. And so this is configure pin functionality. The setup runs once when the Arduino is first powered on. This is where you configure the digital pins to be either inputs or outputs using a function named pin mode. The pins connected to LEDs will be outputs and the switch pin will be an input. Okay, so they have written, let's get rid of this, pin mode 3 output. So I assume 3 is the port on my breadboard which the LED is plugged into. So if I change that, I'd have to change this. Pin mode 4, and this is also an output. So this is a red LED, and 3 was a green LED. Pin mode 5 is my other red LED. Oh, and it's case sensitive, so I need to keep it all proper. Pin mode 5 and pin mode 2 is plugged into the switch, and so that is an input. End of the semicolon, end with curly brackets. So in the loop function, it runs continuously after the setup has completed. The loop is where you'll check for voltage on the inputs and turn outputs on and off. To check the voltage level on a digital input, you use the function digital read that checks the chosen pin for voltage. To know what pin to check, digital read expects an argument. Arguments are information that you pass to functions, telling them how they should do their job. For example, digital read needs one argument, what pin to check. In your program, digital read is going to check the state of pin 2 and store the value in the switch state variable. If there's a voltage on the pin when digital read is called, the switch state variable will get the value higher, or 1, which means it's on. If there is no voltage on the pin, switch state will get the value low or 0. Maybe there's no. Okay, so within the void loop, let's get rid of this one. They've got switch state, equals digital read, without that one, 2. As you can see, if I've written it right, it goes orange, which is good. So I can tell if I'm writing things wrong or not. It's like a spell checker. So I've also got an if statement within this loop. So if switch state equals low, and the double equals means is rather than changing a value. And they've got an open brackets. So the if statement, above you use the word if to check the state of something, namely the switch position. An if statement in programming compares two things and determines whether the comparison is true or false. Okay, so the double equal signs is true. If you use only one sign, you'll be setting a value instead of comparing it. Okay, so I was right. Building your spaceship. Digital write is a command that allows you to send 5 volts or 0 volts to an output pin. Digital write takes 2 arguments, what pin to control and what value to set that pin high or low. If you want to turn the red LEDs on and the green LED off, inside your if statement, your code would look like this. And I'm just going to copy what it says. It goes digital write 3, so that's the pin, high. So that turns my pin on, the green LED pin. Digital write 4, low. And digital write 5, low. Okay. And then I'll finish this if statement with a curly bracket, and then underneath it's got else. So this is the button is pressed. Okay, so this switch state here, and I can write a little comment by putting 2 hashes. The button is not pressed here, and then under my else statement, this is when the button is pressed. Okay. Then it's the opposite. So I'm just going to copy these. I don't have to write them out again. Make it look a bit tidy. There we go. And change these. So it's 3 is low, and then these are high. All right, and I want to finish that else statement. Oh, no, not quite yet. There's something else which goes in here. It's a delay. What does a delay do? So build your spaceship digital write. You've told the Arduino what to do when the switch is open. Now define what happens when the switch is closed. The if statement has an optional else component that allows for something to happen if the original condition is not met. In this case, since you checked to see if the switch was low, write code for high condition after the else statement. Okay, done that. To get the red LEDs to blink when the button is pressed, you'll need to turn the lights off and on in the else statement you just wrote. To do this, change the code to look like this. It has a delay with 250, so that's wait for 1/4 of a second. So those must be in milliseconds. And then I want these ones to blink. So those are my red LEDs. And these should go to low. There we go. And then we need another delay of another 1/4 of a second. I'll close my curly brackets, and then it goes back to the top of the loop. So it will loop through this code here until it will loop through all of it, and then if it's switched on and if it's not switched on, it does different things. So the little booklet says, after setting the I think I've read all that. After setting the LEDs to a certain state, you want the Arduino to pause for a moment before changing them back. If you don't wait, the lights will go back and forth so fast that it will appear as if they are just a little dim, not on and off. This is because the Arduino gets through its loop thousands of times each second, and the LED will be turned on and off quicker than we can perceive. The delay function lets you stop the Arduino from executing anything for a period of time. Delay takes an argument that determines the number of milliseconds before it executes the next set of code. There are 1,000 milliseconds in 1 second, so a delay of 250 will pause for a quarter of a second. And that looks like that's the code. Once your Arduino is programmed, you should see the green light turn on. When you press the switch, the red lights will start flashing and the green light will turn off. Try changing the time of the two delay functions. Notice what happens. Okay, so I need to program this code or upload it to the Arduino, so I shall stop this recording now. Arduino Spaceship code, part 3. So I've gone over putting the breadboard and all the circuitry together. I've then written the code and now to see if it works. So all I need to do is plug it in, and I've uploaded the code already, and so it should have a green light, and then when I press my button, these flash, and then I unpress it and it goes to green light. So it all worked, which is quite exciting.